morning everyone. We are dealing with the chapter Equations of Motion. Okay. So in the last class we have studied about the first equation of motion, isn't it? So what is the first equation of motion? V is equal to U plus AT. Okay. So from today's class you can learn about how to draw a position time graph and velocity time graph. Okay. So what do you mean by position time graph? From the word itself, you can understand that the graph shows the relation between position as well as the time. Okay, look at here. Here you can see a table. Here a table is given. With this data, we are going to draw a graph. Okay, here x-axis. In x-axis, we want to mention the time. The unit of time is second. Okay, so in y-axis, we want to mention the position. Here the unit, the unit also we want to represent there. That is here the unit is meter. Okay, so with this given data, we are going to draw a position as well as the time graph. Okay, so this is the x-axis. Okay. And this is the y-axis, and here you can see O is considered as the origin. Okay, so here x-axis, the scale I have taken here is in x-axis 1 centimeter is equal to 2 seconds. I have taken the scale in x-axis 1 centimeter is equal to 2 seconds. Okay, in y-axis 1 centimeter is equal to 2 meter. Okay, here in x-axis 1 centimeter is equal to 1 centimeter is equal to 1 second. Okay, here 1 centimeter is equal to 1 second I have taken. Okay, in y-axis I have taken 1 centimeter is equal to 2 meter. Okay, that is 2, 4, 6, 8, 10, 12, etc. Okay, I think all of you got it. How the scale have to be taken. Okay, so with this data I am going to draw a graph. Okay, here I mentioned time in second, here I mentioned position in meter. Okay, we want to mention in x-axis the time we want to mention, in y-axis we want to mention the position, and also its unit must be there. Okay, the unit must be there. That is needed to be represented. Okay, while naming a graph, value on the y-axis will be given at first. Once more I will say, while naming a graph, the value on the y-axis will be given at first, then second x-axis. Okay, so in x-axis at time 0, in y-axis the position is also at 0. Okay, so I have mentioned here a point. Okay, then next one, in y-axis the position is 2, and in x-axis the time is 1 second, and here the position is 2 meter, and here the time is 1 second. Okay, so I am going to mention that in this graph. Okay, so I told you that while naming a graph, the value on y-axis will be given at first and x-axis will be given at second. Okay, so in 2 say meter, the time is 1 second. Okay, so here I mentioned that in 2 seconds the position is 4 meter. Okay, in 2 seconds the position is 4 meter. Okay, I have mentioned that. Then in 3 seconds the position is 6 meter. Okay, in 3 seconds the position is 6 meter. Okay, then in time 4 seconds the position is at 8 seconds. Then in 5 seconds the position is 10. Okay, then in 6 seconds the position is 12 meter. Okay. Okay, so it is difficult to put point like this. Okay, so with hyphen I am connecting this. Okay, so it's an easy method. By hyphen I am connecting this. Okay, so I got the real point. Okay. Okay, so I am going to join these all points. Okay. Okay, I got a straight line. Okay, I got a straight line graph from this. Okay, so by connecting hyphen we can easily point out. Okay, I think all of you got it. How to draw, how I draw this graph, how I drawn this graph. Okay, is it clear? Okay, we can draw another graph. Here you can see the distance covered by the car in 8 seconds. Okay, here you can see the distance covered by the car in 8 seconds. From this car we want to find the distance covered by the car in 8 seconds. So we can draw a perpendicular to the position time graph at 8 seconds. Okay, I am going to draw. Okay, I just drawn a perpendicular to position time graph at 8 seconds. Okay, from this 8 second, we can draw another perpendicular to y-axis. Okay, so this perpendicular means the graph. We can draw another perpendicular to y-axis. Okay, I am just going to draw a perpendicular to y-axis. So we can easily understand that the distance covered by the car in 8 seconds is 40 meter. Okay, the distance covered by the car in 8 seconds is 40 meter. Okay, I think all of you got it. How can we see the distance covered by the car in 8 seconds? Okay, I am going to redraw this graph by changing the scale. Here in x-axis 1 centimeter is equal to 2 seconds I have taken. In y-axis 1 centimeter is equal to 10 meter I have taken. Okay, I am going to redraw this graph by changing the scale. Okay, here I have drawn a graph by changing, I have drawn this same graph by changing the scale. Okay, in x-axis 1 centimeter is equal to I have taken 1 second. Sorry, in x-axis in x-axis 1 centimeter is equal to 1 second I have taken. Okay, in y-axis 1 centimeter is equal to 5 meter I have taken. Okay, so what's the difference between these two graphs? Look at here, look at these both graphs. What's the difference between these two graphs? In first graph I have taken x-axis equal to 2 seconds, in y-axis is equal to 10 meter I have taken. Okay, I have redrawn this graph by changing the scale. In x-axis I have taken 1 centimeter is equal to 1 second, and in y-axis I have taken 1 centimeter is equal to 5 meter. Okay, what's the difference in between these two graphs? If I changed these scales, what's the difference between these two graphs? Look at here. What do you understand from this? What's the difference between two graphs? We use scales while drawing a graph. Okay, we are using scales while drawing a graph. Here the only difference is size of the graph decreases as we increase the scale considered. The value doesn't change. Okay, once more I will say, here the difference between these two graphs is we use scales while drawing a graph. We are using scales while drawing a graph. Here the difference is the size of the graph decreases as we increase the scales considered. Okay, there is no difference to the points or anything. Okay, I think all of you got cleared. Okay, next we draw another graph. These two graphs are in uniform straight line. Okay, we got a straight line graph. So these two graphs are in straight line motion. Okay, next we can draw another graph. Okay, using this table we are going to draw a graph. Okay, here x-axis time we want to mention, in y-axis we want to mention the position. Here the data is given. Okay, so I am going to draw a graph. Okay, in 2 seconds, in 0, in x-axis the time is 0, in 0 second the position, that is in meter, is also 0. Okay, so I mentioned here that point. Okay, then next one, in 2 seconds, in time 2 seconds, the position is in 5 meter. Okay, the position is in 5 meter. Then in 4 seconds, the position is in 220 meter. Then in 6 seconds, the position is in 26 meter. In 6 seconds, the position is in 26 meter. Then in 8 seconds, the position is in 44 meter. Okay, in 8 seconds, the position is in 44 meter. Okay, then in 10 seconds, the position is in 50 meter. Okay, in 10 seconds, the position is in 50 meter. Okay, I am going to join these points. Okay. Is this a straight line graph? No, then what's the nature of this graph? It's not a straight line. Okay, isn't it? What's the nature of this graph? It's not a straight line. I think all of you got it, because here the time and position are not equal in equal intervals of time. Okay, they are different in equal intervals of time. Okay, so I got a non-uniform graph. When the graph is in straight line, we can call that graph as the straight line graph. When the graph is not a straight line, we can call that graph as non-uniform graph. Okay, I think all of you got what is the difference between uniform graph and non-uniform straight line graph. Okay, is it clear? Okay, we can move to another section, that is velocity time graph. Okay, look at here. In x-axis, we want to mention the time. The unit of time is second. Okay, in y-axis, we want to mention the velocity. The unit of velocity is meter per second. Here, in 0 second, the velocity is 10 meter per second. Here, there is a peculiarity you can see. Here, the velocity is constant. In this table, you can see the velocity is constant. Here, the velocity is in every time interval, the velocity is 10 meter per second. Okay, so we can join, we can connect these points in this graph. Okay, in 0 second, the velocity is 10 meter per second. Okay, in 0 second, the velocity is 10 meter per second. Then in 2 seconds, the velocity is 10 also 10 meter per second. Okay. In 4 seconds, the velocity is also 10 meter per second. In 6 seconds, the velocity is also 10 meter per second. In 8 seconds, the velocity is also 10 meter per second. In 10 seconds, the velocity is also 10 meter per second. Okay. So, I am going to join this line. I am going to join this line. What you have understand from this graph? I got a straight line graph. Okay. From this by joining these points, I got a straight line graph. Okay. Is it clear? Okay. I told you that while joining the points, we will get a straight line graph. This straight line is parallel to the x-axis, isn't it? This straight line is parallel to the x-axis. Okay. In this velocity time graph, we will get a straight line that is parallel to x-axis. Okay. We want to find out from this graph the displacement of the object between 2 seconds and 8 seconds. Once more I will say, we want from this graph, we want to find out the displacement of the object between 2 seconds and 8 seconds. Okay. 2 seconds and 8 seconds. Okay. 2 seconds and 8 seconds. So, we can draw a perpendicular from 2 seconds to this line. We can draw from x-axis, that is in 2 seconds, from a perpendicular to this straight line. Okay. And also we can draw a perpendicular from 8 seconds to this straight line. Okay. Okay. So I mentioned here at A, B, C and D. Okay. I mentioned here these lines as A, B, C and D. Okay. You understand? Okay. So we can write velocity is equal to displacement by time. Velocity is equal to displacement by time. I told you earlier we want to find the displacement. So we can write displacement is equal to cross multiplying this velocity into time, we will get velocity into time. Okay. I told you earlier that we want to find here the displacement. So, velocity is equal to displacement by time. Displacement by cross multiplying this, we will get displacement is equal to velocity into time. Okay. Is it clear? We know that displacement is equal to velocity into time. Here from this graph, the velocity is AB and the time is AD. Okay, once more I will say, from this graph we can understand that, we can easily understand that velocity is equal to AB and time is equal to AD. Okay, we can say that AB into AD is the area of ABCD. This is equal to area of the portion under the part of C of the graph. So we can say that displacement of a body within a definite interval of time is equal to the area of portion under velocity time graph. Okay, I think all of you got cleared. This is all about today's class. Okay, from today's class we have learned about how to draw position time graph as well as velocity time graph. I think all of you got cleared. Thank you.